everybody, and welcome to the University of Melbourne's mid-afternoon masterclass as part of Science Festival. I'm Julia Claythorne, and I'm going to be your host today. And unfortunately, this is the final masterclass for the whole week. If you didn't know, we've been here at 2 o'clock every day. But of course, we've saved the best to last. Don't tell the other host or the other guests. But I've got Sonja Needs with me. Hello, Sonja. How are you going?
Hi, Julia. How are you?
Yeah, I'm really, really good. I'm super excited for our presentation, or your presentation, should I say. But before I sort of officially hand over to you, I'll just go through a few important things. First of all, just an acknowledgement of country. We are here in the kitchen lab, which is in the Parkfield campus of the university, and the lands of the Wurundjeri people of the Kulin Nation. So just acknowledging the elders past, present and emerging, and the Indigenous people have been looking after this land for over 60,000 years. So we're very blessed about that. And this week of all weeks to really remind ourselves that they are our first scientists. So thank you for joining us for this final mid-afternoon masterclass. We are on Zoom, so a few little Zoomy things. If you don't know, you can swap between presenter view and gallery view on your Zoom. And so if you do want to swap that, if you go to the top right-hand corner, we do recommend going to presenter view to be able to see the presentation properly. Other thing too, we have the chat open, so please use that as much as possible. That's the best place to put any questions you have for Sonja, which I'm sure will be coming thick and fast very soon. And just to get us started as well, open it up and let us know where you're zooming in from as well. Whether it's a suburb, a city, a country. We've had people from China and Indonesia and all over the world this week, so it's been fantastic. And if you're zooming in from a school as well, let us know. It's great to have all the school students in with us as well. So there you go. That's all the stuff done. So we'll come over to you, Sonja. So basically what's going to happen, I'm going to pass over to Sonja. She'll be doing a sort of 25-minute talk or so, and then we'll come back in and hand over to you guys. We'll be able to answer as many questions as possible. I have got your fancy intro, so I'll read that out so everyone knows who you are, and then I'll hand over to you. Right. So, Sonja Needs, a lecturer and tutor in wine, sensory science, climate change adaptation, and animal science. So many things. Yes. She has expertise in sensory science and human and canine olfactory systems. Sonja is particularly interested in how the human olfactory is influenced not only by mechanical physiology, but also how colours, sounds, and textures all influence the way we taste and smell and our abilities to recall different sensory pictures. I'm so excited about your presentation. Yeah. Well, welcome. Thank you so much for joining us. I'm going to jump off screen so we can focus on your presentation. I'll be back whenever I'm needed. I believe I'm going to be doing a little bit of tests, so I'll come back then.
I'll need you.
Yes.
I'll need you back very soon.
Okay. Well, call me when you need me. All right. Enjoy.
Thank you. Welcome, and thank you for joining me in the sensory lab. I hope you have your coriander seeds ready because we'll be doing a little experiment later on. So now, if I asked you what your favourite food is, many people would really struggle to pick just one. Now, what if I asked you, why is it your favourite food? Most people answer with, because it tastes good. But could you describe what you like about that food to a person that's never eaten it before? Is it just about the taste? So I'll make a bet with you that there's more to it than that. So there are so many delicious foods and all of them are different. So we have sweet and crunchy apples, and I've got some here, spicy, savoury curries, earthy, bitter coffee, creamy, sweet ice cream, fresh, crispy salads. So with all of those things in mind, how many things can a human taste? So there's only 6 known tastes. So when I say known, there's 6 tastes that we've proven we can actually taste, and they are bitter, salty, sweet, sour, umami, and umami is savoury, so things like seaweed and tomato, cheesy, meaty. And the newest one, which has just been around for the last few years, now we've always been able to taste it, we've only just proven it to taste, is oligostus, which is fat or fatty or creaminess. The truth is there's actually probably around 10 to 20, and scientists are working on all of those tastes. So there's things like metallic. We think metallic's a taste, but we just haven't proven it yet. Minerality, which is the opposite to acid, it's sort of an alkaline taste. And kokumi, which is one I'll talk about a little bit later on today as well, which is that savoury richness that you get when you slow cook foods or when you roast foods. Now, we detect taste with our taste buds, and taste buds are fascinating. So children have around 10,000 taste buds, but we lose around half as adults. So they're located in structures called the papillae. So we got a slide for this one. So they're located in structures called the papillae, and they're what we would most of us look at our tongue and we see those little bumps on our tongue. And now some of those bumps are papillae with taste buds in them, but they're on the tip of our tongue, on the sides and the back of our tongue, but we also have some in our cheeks and the roof of our mouth. Now, each papillae contain between 3 and 100 taste buds. So each of those little bumps isn't a taste bud in itself. Each bump contains taste buds. Now, the ones you see on the tip of your tongue are called the fungiform papillae. They look like little mushrooms, and they have between 3 and 5 taste buds. On the sides of your tongue, we have the folate papillae. Right at the back of the sides, we have some folds. They're the folate papillae. And at the very back of our tongue, in a big V section, we have the circumvallate papillae. Now, the folate and circumvallate papillae have around 100 taste buds in each of those little papillae. Now, each taste bud, so stay with me here. So we've got 3 different types of papillae, and each of them have between 3 and 100 different taste buds. Now, each taste bud has between 10 and 50 sensory cells, and they're arranged like the segments of a mandarin. So arranged inside the taste bud like the segment of a mandarin. Now, each of those individual sensory cells within each taste bud, they have slightly different roles. So some give the brain information about whether a taste is present or not. So we've got our little sensory cells arranged like a mandarin or like my fingers, and some of them, one cell might say this is salty, that one might say that it's sweet, this one might say that it's bitter. So each of them will either tell us whether a taste is present or not, and some of them will tell us about the concentrations of that taste. So it tells about the intensity of the taste. Is it very salty or is it very sweet? So each of those little cells have different roles. Now, all taste buds can detect all tastes fairly equally. However, we think the taste buds at the back of the tongue and the circumvallate papillae are more sensitive to bitter. And the reason for that is because often things that are toxic or poisonous are bitter. And by having that circumvallate papillae, that is a sort of a line of defense. So if you eat foods that are a bit bitter, it can invoke the gag reflex and stop us from eating toxic foods. So can you get your coriander seeds ready? So if you've got a coriander seed, get it ready, because we're going to do a little experiment in a minute. Now, it's more to taste than just your taste buds, and you might have guessed that. So what I'm going to get you to do is take your coriander seed. It's really hard to see this little tiny coriander seed I have here in my hand. We're going to get our coriander seed. And what I want you to do, now it's really important you try and not run ahead, but what you're going to do is smell a coriander seed. Now, you smell a seed, and what can you smell? Does it smell like anything? What you probably can smell is your fingers, because the coriander seed really doesn't have any smell. So now what I want you to do is to put it into your mouth. Don't chew it. Make sure it's a whole coriander seed. Now, thinking about where our taste buds are at the tip of our tongue, you're going to put that coriander seed into your mouth, and I want you to suck it. So try and roll it around the taste buds on the tip of your tongue. Can you taste anything? So hopefully the answer to that is no. You shouldn't be able to taste anything, because the coriander seed, it doesn't really taste like anything. Now, this is the important bit. Keep that coriander seed in there. I want you to pinch your nose, and you need to pinch your nose hard enough that no air will come through it. So pinch really hard. Now, once you're pinching your nose, you can start to chew the coriander seed. So start to chew. Keep pinching your nose, keep holding it. Now let the coriander seed go. And what you should find is when you let your nose go. So when you let your nose go, after you've chewed that coriander seed, when you've got your nose pinched and you're chewing the coriander seed, you won't get any taste, because the coriander seed is not bitter, salty, sweet, sour, savoury or fatty. It has no taste. But when you let your nose go, what happens is a thing called retronasal olfaction. When you chew the coriander seed, you're letting go volatile organic molecules. So the smells, the aromatics of the coriander seed. And when you let your nose go, the air from your mouth is drawn up through an opening at the back of your throat or at the back of your mouth, up into your olfactory system. And what you're actually doing is smelling those volatile organic molecules or the odorants, and that's called retronasal olfaction. So when you smell at the front of your nose, it's called orthonasal olfaction. When you put foods in your mouth and you chew them and you get all of those amazing flavors that you're getting now with that coriander seed, that's called retronasal olfaction. So that little seed, you should now be getting what your brain will be telling you is the taste, but it's not taste at all, of sort of spicy and maybe a little bit citrusy on your tongue. Now, if your brain's telling you that you're tasting that on your tongue, that's actually a thing called oral referral, and that's a mislocalization of food-related olfactory stimuli to the tongue, because it's nothing to do with your tongue. You are literally smelling that coriander seed retronasally. So that brings us to flavour. Taste is only bitter, salty, sweet, sour, umami, and fat. Flavour that we tend to describe, so things like we might describe foods as earthy, so like chocolate and coffee, mushroom, fruity, citrus, berry, tropical, spicy, so things like vanilla, cinnamon, pepper, they're all spicy, herbal or vegetal. All of those things that we describe when we're talking about flavour are actually aromas that we're perceiving retronasally through our mouth. So not anything to do with our taste buds, but everything to do with our olfactory system. So what most people don't realise is when they say something tastes good, often what they're talking about, if they're talking about the flavour of those things, they're actually really meaning that it smells good, just retronasally. So detecting an odour, all of the flavours that we get from our food are actually those volatile molecules called volatile organic compounds, VOCs, or you can just call them odorants. Now, as air with an odorant molecule is drawn into the nose, they come into contact and bind with odour receptors or odorant receptors. And this process is often called the lock and key principle, with the odorant, so the smell, so in this case with the coriander seed, the smell of that spicy and citrus being the odorants, and the key, so they're the key, and the receptors where those keys fit into to tell our brain that we are actually detecting them, that is the lock. So the lock and key principle. So the keys are the odorants and the locks are the receptors that tell us that we can actually smell them. So the reason we call it the lock and key is because the receptors are particular for the odors. So not all odors will fit into all receptors. They have to be specific for the odors have to be specific for the receptors. So if you look at that diagram, at the right, you will see that the yellow coloured receptors will only receive odorants that are triangle shaped. And the blue receptors only receive odorants that are square. Now, that's a very simplified version of what actually happens, and each receptor or lock can actually receive many combinations of odorants or keys, but most receptors will only receive certain amounts of odorants or keys. So this brings us to our poll question. Who likes the smell and taste of the herb coriander? So this is not coriander seeds. So coriander seeds are quite spicy and citrusy. Most people get that. What about the herb coriander or cilantro? Who likes the smell and taste of that herb? Now, personally, I love it. I love coriander, and I like to put it in all my foods because I find it freshens and lifts foods. So what are our polls saying about this?
Right, 94% yes and 6% no.
Wow, 94% yes. Wow, that's good. Often we get quite a lot of people, you never sit on the fence when it comes to coriander. You either love it or hate it. And often it's a lot more. We often get about a third of the people not liking it. Now, if you love coriander, it is fresh, it's herbal, it's a little bit floral and citrusy. If you don't like it, it will smell and taste either soapy or, even worse, like smelly socks. So it can be really horrendous. Now, why is it that some people smell coriander as being fresh and herbal and beautiful, and other people get smelly socks? So the reason is that the receptors that we have, our odorant receptors, give us information on how we perceive an odor, so whether we like it or dislike it. Now, with coriander, the odorant key that opens the receptor that tells us that the coriander has flavour, of either soapy and smelly socks or fresh floral herbal. The thing is with the receptors, it's genetic. You either have a receptor that tells you just that it is soapy, smelly socks, or genetically you don't have that receptor, you have the fresh floral herbal receptor. So one key, the coriander key, one key, but two receptors. So one key opens two locks, and genetically people either have the soapy, smelly sock receptor, or they have the beautiful fresh floral herbal receptor. So it's why people either love it or hate it. And it's completely genetic, whether you like it or not. If you detect it as being soapy, smelly socks, you will never, ever get it as fresh floral herbal, because you don't have the receptor to get fresh floral herbal. And if it's fresh floral herbal, you won't get the smelly socks, because again, you don't have the receptor for it. So there's a lot of genetics when it comes to what we taste and smell and whether we like or dislike foods. Now, foods are not one volatile organic compound, but many in combination. So even coriander, there's not just one volatile organic compound, but many compounds that make up the smell of coriander and the taste of coriander. So each food we eat has many of these volatile compounds. When we combine them, it makes a recognisable flavour. So a really good example of this is the flavour of cola here. So cola is a combination of, in general, so if you're drinking branded Coca-Cola and Pepsis, they'll have lots of different other aromas, but the general aroma of cola is a combination of lemon or lemonine, which is a citrusy flavour, vanilla or vanillin, which is a sweet flavour, and clove or eugenol, which is a spicy flavour. Now, if I had lemonine, vanillin, and eugenol in the right combination and I mixed them together and wafted it under your nose, it will smell exactly like cola. Now, foods have many, not just three, but most foods have hundreds of different volatiles that combine to make them a recognisable food. So foods like coffee, for instance, they have over 700 known volatiles which can be present. Now, they won't all be present in the same cup, which is why we have a preference for certain coffees over another. So if you go to a coffee shop and you particularly like the coffee there, it may be a barista that's making a good cup, but quite often it is actually the beans that they have. And the beans that they have will have different volatiles being produced by the coffee beans themselves, but also the roasting and the way they make them will release different aroma profiles. So some coffees can be quite earthy, some are fruity, some are spicy, and you will have a preference for certain coffees. So, all right, Julia, do you want to come and join me?
Hello.
Hello. So I've got a little experiment. Let's have a look at how these volatile molecules work. So, Julia, I want you to close your eyes, and I want you to tell me what you are smelling. So, can you smell this? What's that?
Okay, now I have been informed it's apple, but is it? I think that smells like green apple.
All right, now smell this one.
Oh no, actually I don't know. Okay, I think I need to smell the other one first.
Now that's the first one.
Okay, that smells like red apple.
That's the second one.
And that smells like green apple.
Okay, you can open your eyes.
Yes.
You're right. Okay, so red apple, green apple. Okay. So you can obviously smell the difference.
Yes.
Because they don't smell the same, do they?
No.
They both smell like apple though, don't they? Yeah. So they smell like apple, but they don't smell the same. So red apple, green apple, both smell appley, but if you can tell the difference, why can you tell the difference? So can you describe for me, without using the word appley, what they smell like? Now, what you need to keep in mind here is that we can't smell bitter, salty, sweet, sour, umami. So you can't actually say, you can smell savoury a little bit, but you can't smell it, you can't say it smells acidic or sweet.
Okay.
Or appley. So how would you say describe the red apple for me? So you can take that glass, have a smell, tell me what aromas you think it smells like.
Okay, so it's definitely stronger than the green. I definitely noticed that, and like like, yeah, stronger, like earthy, honey sort of
Perfect.
vibe. Yeah.
Yeah, perfect.
Yeah.
So red apple in general, so red apples, this is a pink lady apple, and they're often, so they have more than 300 different volatile organic compounds in red, 300 different smells that you can get out of this pink lady. Most of them are things called alcohol esters. So esters are really what you get with fruits and flowers and things. And they're characteristically described as fruity. So this is much fruitier than our green apple. A red apple will be fruitier in smell. Oh. And it's often described as, red apple is often described as fruity. Melon and pineapple. Honey is also that honey sort of characteristic which you described. So you're spot on. Green apples tend to be a little bit less aromatic, and they're often described as grassy or even like lemongrass. So
definitely more subtle.
Yeah, much more subtle, less aromatic is the word. Yeah, really good. All right. Okay. So yeah, you can pop on.
Thanks.
All right. So taste and smell can invoke really strong memories. So when you smell certain things, often memories pop into your head. So a lot of people have really good memories about, say, the smell of a pine tree. It might remind you of Christmas. For me, newly mown grass always reminds me of weekend sports and summer. So whenever I smell that fresh cut grass, if I go somewhere, I smell fresh cut grass, I just think, oh, summertime, weekend sports, amazing. So the effect is likely to be the result of how smell is processed through the parts of the brain that are associated with memory and emotion. And it's why food can make us quite emotional, but it's also how we remember smells and remember tastes. So it's likely that being able to remember smells and tastes so strongly helps with the phenomenon of a learned taste aversion. So imagine if you taste something, or you're eating food and then you get food poisoning. Anyone that's ever had food poisoning, usually the last thing that you ever ate when you get food poisoning, you will never eat that thing again. And that is a taste aversion, because your brain is telling you that's the last thing you ate and I got sick, never eat it again. So it's a really powerful evolutionary aid to help avoid potentially eating poisonous substances. It also will inform us on things that we like. So if you eat something when you're in a really good mood and having a good time, those foods you'll learn to like a little bit more. So I suspect that that's where party food comes in. So kids, party food, sweet things, having a great time, eating fairy bread. We all seem to have a really nice affinity for fairy bread. So young children and babies, they tend to be naturally averse to bitter and sour tastes. And the reason for that is bitter, like I said earlier, is related to toxic foods, and sour is often foods that are not ripe. So we don't want to be eating things that are not ripe because they can give us a stomachache. So young people tend to be quite averse to bitter and sour, but as we get older, we can actually become quite accustomed to the taste and even to crave bitter and sour taste. And that's where coffee comes in. Most young people, most children and teenagers aren't overly keen on coffee, but as you get older, you want more coffee, and you might start off drinking lattes and you end up drinking, espresso black coffees that are really bitter. So we learn to actually like those tastes that we were, as young, quite averse to. Now we've got another poll question. So the question is, what taste would you match with the colour pink, or even red, but pink and red? What taste would you match with that colour? So thinking bitter, salty, sweet, sour, umami and fat, what would you match with the colour pink? So close your eyes, think about pink. What taste goes with it? Bitter, salty, sweet, sour, umami or fatty? What's our poll saying?
Okay, overwhelmingly sweet.
Yeah, pink. So there's some really cool research done on colours, and it's shown that we often associate colours with tastes and aromas. So pink and red, you're all spot on, sweet. We associate sweet things with pink and red. Green, we associate with, just think about it, what comes into your head? Bitter, salty, sweet, sour, umami, fatty. Green is sour. Brown is bitter. And I did this earlier with the people in the room here with me, with Julia, and Julia was absolutely spot on. Green was sour, brown was bitter. Now, this is most likely to do with a learned response that help us determine what foods or what to expect of foods before we eat it. Now, if we think about red and pink and fruits are ripe, and the riper they are, the more red and pink they go. And probably yellows and oranges fit in with that category as well. If we're thinking about fruit, when it's green, what is it? It's going to be a little bit sour. So colours, we can associate them with taste. And it's a really interesting marketing tool for marketing companies, because marketing companies will actually use this in their wrapping and even when they're using colours in foods. So making a food pink or red will make us perceive it as being sweeter than it actually is. We don't need to add the sugar, we can just add the colour. So we also associate smells with taste, such as the taste of vanilla. Now, most people are really surprised at this one. What taste is vanilla? So most of you would probably say vanilla is sweet, bitter, salty, sweet, sour, umami. What taste is vanilla? Sweet. And you would all be wrong. So most people would say vanilla is sweet, yet vanilla, and when I'm saying vanilla, I'm not saying vanilla essence, I'm saying the actual vanilla bean. Vanilla has no taste. Just like our coriander seeds, it has no taste. It's neither bitter, salty, sweet, sour, or umami. But we very strongly associate it with sweet things, and marketing and product companies that are making food will actually use that very effectively. They put vanilla into foods to give us the perception that that food is actually sweeter than it is. So have you ever wondered why some ingredients seem to have a natural affinity for each other while other combinations just seem wrong? So a perfect pairing of food will be either two things. They could either be congruent or complementary. Now, two or more ingredients are congruent when they share key components. An example of that is the beautiful match between strawberries and cream. So strawberries and cream both have a whole range of volatile organic molecules that are in common. And one of those is acetonin, which is a sort of a creamy, almost caramelly aroma compound. And when you put the cream with the strawberries, it enhances, because it's congruent, the two aroma compounds being similar, enhances that beautiful, creamy, caramelly sort of aroma and flavour. So congruent is when they share key components. An odd one, and now don't try this until you knock it, a really odd one here, and it's worth trying at home if you can, is blue cheese with chocolate. Now, blue cheese and chocolate share over 70 different aroma compounds. And it sounds weird, but you get a piece of chocolate, get a piece of blue cheese, stick it on top and eat it, and it actually goes really well together. So congruent works best with matching aromas, because if we match the tastes, such as sweet with sweet, so two sweet foods together, or bitter with bitter, it can make the taste really overpowering and unbalanced. And if we want to pair and match foods, what we're looking for is balance. So most Western cuisines are congruent. So when we are making recipes, we're actually looking at matching compounds. The other one that we have is complementary. So complementary foods have different compounds that go together well, but share no common aroma or flavours. So a good example is fish and lemon. So the creaminess of the fish protein balances the acidity of the lemon really well. And most Asian cuisine works on the theory of complementary. So Western cuisine tends to be congruent, Asian cuisine tends to be complementary. So pairing is also about getting the mouthfeel right. So a mixture of textures will help to excite the senses and enhance the dining experience. And certainly that complementary works well with that. So tastes that go well together that are not the same. So the combination of both the volatile compounds and the taste that make our food what it is what we think about complementary and congruent. And then there's a thing called mouthfeel. So mouthfeel, or technically somatosensory information, is about the nerves in the mouth which detect texture. So this is another sense, isn't it? So we've talked about taste and smell and colour, and this is texture, this is touch. So the nerves in your mouth detect the texture, the temperature, and temperature is really important as well, and other information from the foods we eat. So hot, as in chili, spicy food, is often described as a taste. So a lot of people think that spicy is a taste, but technically it's actually a pain signal sent by the nerves in your mouth that transmit touch and temperature sensation. And menthol, which is felt as coolness, so thinking peppermint and alcohol, that's also a pain response. So chilies and menthols are both pain responses that are to do with texture rather than actual taste or smell. So next time you're preparing your favourite meal, you need to think about incorporating components to stimulate every sense. Don't just think about the tastes or the aromas, but think about incorporating everything. So improve your eating experience by incorporating all of your senses to help enjoy your meal considerably more. Bon appetit.
Amazing. Well done. I'm just going to clap on behalf of everyone, which I'm sure everyone's clapping on Zoom as well. Thank you so much. That was fascinating.
Good.
I was literally writing notes as you were talking because I just think there are so many things that I mean, I would want to ask more questions, but I know there's already lots of questions in the chat. So everyone out there, if you've got questions, please put them in the chat. We'll try and get through as many as possible. There's lots already that we want to hear from you. So let's get into it. You ready for some questions?
Yes.
All right. So first one was from Suresh, who was very early on. So first question in, can we train our receptors to identify certain smells and flavors?
Yes. Excellent question. So with smell, smelling things is a little bit like working out at the gym. And the more you smell, the better you get at it. And this is actually what I do for a living here at Melbourne Uni. I teach people how to smell different foods and how to pick out different aroma and smell. You can, by smelling something a lot, you can actually become much more sensitive to it. If you smell it too much, you can actually become almost desensitized to it. Yeah. So people that work in very smelly industries, so if you work in a piggery, for example, you can actually get like fatigued out on it. So and then to the point where you can't smell it at all. But if you've got something that you want to smell more, if you want to be better at smelling and detecting aromas, the more you smell, and you need to actually think about, as you're sniffing, what the aromas are. So think consciously about smelling and what you're doing, and you certainly those receptors become more and more acute to be able to pick up smell. So yeah, it's literally like working out at the gym.
Love it. That's so great. Great question. Great start. All right, next one from Linda. So is there a link between the perfumes and the tastes we prefer? So floral and musky smells. So I guess it's the perfumes we smell, I guess, and choose to wear, I guess.
I don't know whether there's any research on this. It would be an interesting research.
Yeah.
I suspect if you like floral, fruity aroma on your body, you probably would like those sort of foods as well.
That's the hypothesis.
It would be a really interesting research project though. But yeah, I suspect there probably is some.
Well, go on, Linda. Maybe it's a research project
waiting to be done. That's right.
Perfumes though, it does remind me, seeing that cup of coffee. So you often see that at perfume stores to like what is it, reset your taste or what's I'm sneaking a question here.
Such a myth.
Oh,
such a myth. I'm glad you did that. So a lot of the time you'll get coffee, and when you're at perfume or if you're at a wine tasting, and you'll be tasting the wine or smelling the coffee, and they say smell of coffee. The thing is, the very next perfume you smell after smelling this coffee, what's going to be the overriding? The next perfume is going to seem a little bit earthy, a little bit coffee-ish, because you've already got this in your brain sniffing away. So it doesn't actually help you reset. Now with perfume shops, the interesting thing is the problem with perfumes is we put them on our body.
Yeah.
If you were doing wine tasting, you've got your body that you can use, and the best way with wine tasting is if you're smelling a wine. So after smelling it, if you're starting to be a bit overwhelmed, the way you reset your nose is to smell the back of your arm, and your own aroma is your reset. And you'll find when I'm doing long wine tastings with students, you get a bit of a headache, And by smelling the back of their arms, straight away you get a relief in your olfactory system. So as long as you haven't got perfume on your body, if it's just your natural scent. Now, don't smell your hands because your hands smell like everything you ever touch, but the inside of your arm is your reset. Of course, it doesn't work if you've just sprayed perfume all over your arm. So coffee and tea bags is the other one that you can use. It will give you something else to smell, but if you're smelling perfumes and you smell a tea bag, the next perfume will have that sort of herbal aroma. If you're smelling coffee, the next one will be a little bit earthy. So, yeah.
So it's a complete myth. Why is it there then?
It just gives them something else to do. So if you smell
distraction.
Yeah, so if you smell something for long enough, so if you stick your nose, say into this coffee, if you sit for more than 10 seconds, your nose will start to do a thing called nose fatigue. So it's olfactory adaptation, and it's a really handy little human response that we have, and only really humans do it. So it's like if you walk into a room and there's like, if you've got teenage kids, you walk into their room and like their bedroom smells like dirty socks and you think, oh,
coriander.
And once you're in there for any length of time, you realize you don't smell it anymore. It's not because the smell's gone away. It's because you've got nose fatigue. The same with when you put perfume, you know, the Lynx effect. You spray perfume all over yourself, you go, I smell beautiful. And then by the time you get out the door, you think, I can't smell it anymore. And it's not because you don't smell like perfume, because your nose is fatigued out. So we have olfactory adaptation. And so smelling anything for too long will give you fatigue. So if you go from a perfume to coffee, it just resets your nose a little bit.
Okay. All right, very good. Okay. Next up, so from Michael, can alcohol interfere with taste buds or result in delayed perception, interpretation of taste?
So it can enhance, depends on how alcoholic something is. So with beer and wine, alcohol, what it adds to beer and wine is structure. So non-alcoholic alcohols, so our low nose now that we have, one of the things you'll notice is that the texture of them is actually quite different. So alcohol adds a whole range of texture. So that mouthfeel that I was talking about, super, super important with wine and beer and spirits is the mouthfeel. And when we remove alcohol, we lose the mouthfeel. It doesn't necessarily interfere with our taste buds. If you've got very strong alcohol, we get it. It's a massive irritation response. So with strong alcohols, we'll get quite irritated. And so it's not that we can't taste the smells and the aromas, but that we have a bit of a aversion response to that. But again, the more you drink, you can actually learn to put up with that. So, but yeah, alcohol, the main thing alcohol does is give us a textural mouthfeel. So it's important for mouthfeel more than anything.
Right. Okay. All right. So another one. What is the role of emotions in taste?
Oh my goodness.
Is taste a reflection of one's state of mind? Can mood enhance or dampen taste of food?
Very much so. And there's a lot of research on this. So yeah, emotion is very strongly mixed into, and because of those memory centers. So if you are in a really good mood and you eat a particular food, it will seem better. So if you're in a really bad mood, nothing will seem to pick that up. So you can eat the best food in the world, but if you are feeling ill or angry or sad, the best food in the world will seem okay.
Yeah.
But if you're in a really good mood, you could eat fairly mediocre food and it will seem amazing. So a really good example of that is wine. So a lot of people have like unicorn wine because they've drunk it when they've been on holiday with their friends and listening to even the sounds that you're listening to. So listening to music that you like and in a really good mood, and you'll taste that one and think that's amazing. Or taste that food and think that's amazing. And then you go home and you have it and you're like, why is that not quite as good? But the memory centers will trigger us to say, this is good. Remember, this was really great when you had that. So very, very strongly linked. Our emotions are very strongly linked to flavors and aromas. Yeah.
Amazing. Great question. All right, on to one from Jess. So I absolutely agree with this one, Jess. I'm glad you asked it. Why do I crave something sweet after eating dinner or lunch? Is it because we are conditioned to have dessert as a course?
Yes.
Yeah.
Yeah.
All right.
Yeah, and it's a bit of a Western thing as well.
Okay.
So yeah, a lot if you come from an Asian culture, they don't tend to have the sweet things after a meal. And often with the meal they have sweet things. So yeah, it is definitely a learned response, the sweet things, and you can train yourself out of it just as easy as we've trained ourselves into it as well. So
yeah, amazing. All right, so I think we've maybe got time for one more question. So what this is from Amy. What is it in smells that invokes headaches or nausea?
So it could be a learned response. So I mean, some smells we have an aversion response to because they literally, our brain will tell us that smell is a bad smell. So keep away from it, stops you from putting it in your mouth. So as a baby, hopefully they smell bad things and they pick it up and go, oh, it's not bad. So it stops them from putting things that they shouldn't put in their mouth. So there's a little bit of instinctual work going on there. So anything that's got, again, bitter, sour, and there's a whole heap of aroma molecules that fit with that, that is just instinctual for us not to eat. Don't put it in your mouth. But there's also quite a lot of foods that will make you feel perhaps nauseous or not well when you smell them, that might be actually very much a personal thing, depending on your experiences that you've had growing up. And like I said earlier, if you were eating food and then you get sick with gastro or you get food poisoning, you may then every time you smell that food be quite averted to it. So I have a major aversion. I don't particularly like the smell of anise. It makes, because I got sick straight after I'd eaten some anise, some foods that were quite strongly aromatic with anise. So now every time I smell it, I'm actually working to get over my aversion. So, but yeah, and which you can get over some of those aversions.
I had that with spaghetti bolognese when I was 10.
Can't stand the smell
I
of
could have bolognese and I could have spaghetti, but I couldn't have them together. All right, so just a couple minutes left. One really important question, pineapple on pizza, yes or no?
Yes.
Great. Okay, that's the official word from the researcher. Thanks very much. All right, and so as I've asked most of the guests, what do you feel like is the next thing? What else do you want to be finding out? Apart from obviously, what was the question we had about the
perfume?
The perfume. Okay. So that's going to be Linda's one. What's going to be your next? What's your sight set on?
Oh, so many things. So many things. We're actually doing a whole heap of work on native foods at the moment. So looking at what the aroma compounds and the flavour compounds are coming out of a whole heap of indigenous and native foods, and that's super exciting. Lemon myrtle is like such an amazing one because there's more citra, which is that citrusy aroma that you get in lemon. It's really like that really lemony lemon. There's actually more citra in lemon myrtle, in Australian lemon myrtle, than there is in lemons.
All right.
So it makes it a really powerful flavourant for food. So we're looking at a whole range of different Australian natives at the moment, and for me that's super exciting to look at how we can use them better for flavour and aroma compounds in cooking. And everyone's using them now, so trying to use them a little bit more. Super exciting.
That's super exciting. We're looking forward to seeing what comes of that. And now final question, I think I might have said that was the final question, but this one's what's for dinner?
For me, tonight I love cooking, as you can imagine.
I bet.
So tonight what are we having? I'm actually doing a caramelized onion, mushroom, and goat's cheese tart with a little bit of thyme.
Delicious. So, all those senses and tastes are being completely complemented.
Sweet, earthy, spicy, the whole lot. Beautiful.
Amazing. All right. Well, thank you so much. Everyone, add in the chat what you're having for dinner in case someone doesn't know, because maybe we can have a bit of inspiration. And as you're doing that, I will finish up. So thank you all. Thank you so much for coming today and all week to these mid-afternoon masterclasses. It's been an absolute joy to talk to everyone, particularly yourself, Sonja. So thank you. It's been a great science festival. So we that's it for 2023 mid-afternoon masterclasses, but there's lots more events happening at the University of Melbourne throughout the year, so please keep that to the events website. But other than that, thank you so much. Have a great Friday afternoon. And thank you so much, Sonja.
Thank you.
Amazing.